View of pipes and unions in aircraft. Pipes and hoses form the circulatory system of an aircraft, carrying fuel, hydraulic fluid, oil, pneumatic air, and de-icing fluids. This system rely on two principal families: rigid fluid lines and or fixed routing, and fixed hoses for movement and vibration absorption. Correct selection, joining, and routing of pipes and unions is essential for safety of aircraft, leak prevention, and long-term reliability. Primary functions of pipes and unions is transfer fluids and air, contain pressure, and isolate system when required. System types: fuel, hydraulic oil, pneumatic, and de-icing system each demand tailored material and fittings. Reliability needs: resistance to corrosion, high temperature, pressure cycles, and vibration are key design drivers. Material used for rigid pipes are stainless steel, aluminum alloys, tungsten, titanium. Titanium is approximately 30% stronger and 50% lighter than steel, chosen for high pressure hydraulic system above 1500 psi where weight saving is critical. Types of pipe fitting and union. Fittings and union create joints that must remain leak tight under varying pressure, temperature, and vibrations. Selection depends on system types, accessibility, and whether the joints must be removable or permanent. First is flared fitting, common across many pressure systems. Provide mechanical sealing via flare tube and mating nut, reusable when correctly assembled. Second is flaredless fitting, used when flaring is impractical or would weaken the tube. Compressive seals achieve reliable leak resistance under pressure. Bead and clamp, simple, robust, and low medium pressure and vacuum lines. Quick to assemble but require correct clamps and torquing to avoid slippage. Fourth is permanent fittings, which is swagged and cryofit. Provide high integrity permanent joints used when disassembly in not intended and maximum integrated is required. Fifth is standard unions. Provide detachable connection between pipes across hydraulic, fuel, oil, and pneumatic systems. Ensure correct seal types and torque for pressure ratings. Flexible hoses. Constructions and classification. Flexible hoses enable movement absorption, vibration, and correct dynamic component. Their layered construction is engineered to match pressure, fluid compatibility, and durability requirements. Inner line. Seamless synthetic rubber or PTFE Teflon, selected for chemical compatibility with fuel, oil, and hydraulic fluid. Reinforcement. Cotton braided for low pressure, metal wire braid for medium to high pressure, and determines purse strength and flexibility. Outer cover. Rubber impregnated braid or abrasion resistance cover protect against chafing, heat, and environmental exposure. Pressure classifications. Low class is 250 psi, medium is 300 psi, high design rated 300 and beyond. Always use hose rated for the system maximum working pressure and temperature. Identification and markings on pipes and hoses. Accurate identification prevent incorrect replacement and assembly errors. Markings and physical identifiers give technicians the information needed to match parts precisely. Rigid pipes, and identified by material, nominal diameter, and wall thickness, traceable to drawing numbers and parts code in the IPC. Second is flexible hoses, marked with manufacturer, part number, date of manufacture, and a lay line to detect twist during installation. Third is color coding and tags. Color coding, example yellow for lubricant, and durable tags help rapid system identification. Replacement component must match original specifications exactly. Safety and installation best practice. Working with pressurized fuels. System require strict procedural discipline. Follow isolation, personal protection, clean assembly, and routing standards to prevent injury and maintain the system longevity. First is isolation and lockout. Isolation pressure sources, placards control and confirm zero pressure before opening any fitting. Second is personal protective equipment. Wear eye protection, gloves, and protective clothing. when draining system or working on pressurized lines. Third is protect thread and seals. Use a cardboard or protective caps on fittings to prevent seal damage during handling and assembly. Fourth is spill management. Contain and clean fluid spillage immediately. Large spill require emergency response and possibly the fire brigade. Routing and clamping. Provide adequate clearance, secure routing and correct clamp spacing to avoid chafing. Heat contact and undue strains on fittings. Summary: mastering pipes and unions for air safety. Correct material choice, compatible fittings and disciplined installation are vital to maintain system integrity. To identify torque and routing standards, follow safety protocols for pressure isolation and spill control, and always reference the illustrated parts catalog for exact replacement part. Proficiency in pipes and union directly contributes to airworthiness, operational reliability and passenger safety. Match material and fitting system pressure, fluid and temperature requirements. Use correct hose classification and observe manufacturer marking for replacements. Always isolate PPE up, personal protective equipment up, protect seals and clean spills. Safety first. Thank you.